Chapter 8, Necessity Modals and Intentional Semantics. In the last chapter, we gave an analysis of the translation of sentences like John may win, John might win, etc. And they all had a form that we could simplify as follows. Take the word modal here to be either of the words may, might, can, or could. Then the sentence John modal win was translated as for some W, there is a W, R, W, actual world, and win, W, John. And the modals differed only here in what the restriction was that was placed on the worlds being quantified over. Everything else remained the same. So for example, in the deontic case, RWW at was the rules in the actual world are followed in W. By using rules, we ended up getting permission. In the epistemic case, it's not rules that counted, it was knowledge. And so R ends up being what is known in the actual world is true in W. That would quantify over worlds that hold everything that we know constant. And for teleological modals, those are the ones with a goal of some sort. It was quantifying over worlds where circumstances in the actual world hold in that world. Okay, but we didn't ask the question of how do we get this interpretation out of the parts. So that's what I want to start with today. Until now, we've been assuming that the interpretation of a word like win is a one-place predicate. It's a function from individuals to a formula in which that individual occurs. So it's lambda x, win of x. But in our new analysis, win is no longer taking just a single individual. It also has a world as an argument. That is, we have something of the form win W prime x. And that means we need a new analysis. We can't use the old one anymore because the old one doesn't involve worlds. So we're going to give this as our new analysis of win. It's going to be lambda W prime lambda x win W prime x. And we'll take win W prime x to mean that x wins in world W prime, okay? Now this involves a couple of changes, and the changes then we need to make adjustments for. The first one is we have this new type. A world is now given a type, and the type is S. The old types are still there. This is of type E. This whole thing is something true or false. It's going to be of type T. And so our new type for win is this, SET. That can be seen as a function from worlds to a function from individuals to truth values. With this as a background, then we need to figure out how to translate may. And the idea is that we give a translation that will end up producing the result that we want. The result we want is John may win is going to have this form with R. We're going to just leave R as R, okay? And so then what do we have to have for may? And this on the top line here gives us what we want. We want something that takes a predicate. This is going to be something like win, which we just saw as a function from worlds to a function from individuals to truth values. It gives back something that's going to have to take another argument. That other argument will be John in the end. And it gives us basically well, the rest of that formula that we want with Win and John taken out. So there is a W. It has our RWW sub A, I'll call that. It has P of W of Y here. And that P of W of Y part, that is telling us that we take the predicate, Win in this case, apply it to a world, the world quantified over here, and apply it to the individual quantified here. So I'll just step through this very quickly. It's a mechanical process. You take may win and you break it down into two pieces. It's got may applied to win. And so we copy may here. And we copy the translation of win here. And this is going to have to substitute for P. We give back the rest starting with lambda y, so that is this. Where win has been substituted into this position. So the next thing we have to do is take that and apply it to its first argument, w. That w has to replace this w prime, and we'll give back the rest, which is lambda x win wx. That's still a function that needs to apply to an argument, and it's given an argument, y. That y has to substitute for x, and so we end up with win wy in that position. So may win ends up as a predicate. That'll take an individual, and it'll give back this kind of a complex formula. The translation of John may win takes the translation we just gave for may win and applies it to the translation for John. Translation we just gave is here. Copy it from the previous page, that's what you get. The translation of John is just the individual named John. And so that John gets substituted in place of Y, and we get back as our formula for the whole sentence, exactly what we were trying to get back. Okay, so this makes, this is just a simple way of using the same mechanisms that we've already used, but adding in worlds as arguments so that we can use words like may, the modals, to quantify overworlds. It causes a little bit of a problem for other cases though, and we're going to have to do something about that. In particular, think of the sentence John wins. There is no modal in John wins, it's just John wins. But if we take win to be the same thing that we just gave for the modal case, well, the first thing it needs is a world as an argument. We can't then take win and apply it instead to John. That's the wrong kind of a thing, right? We want a world that can go into this position. John is an individual. It's going to eventually want to go into this position. But what do we do with the world then? If we take win to just be what we've always taken it to be with no world argument, then we can get past that problem. Win applied to John is going to be defined. However, that requires putting a different predicate win here from what we have in the case of John may win. Those are different predicates, and as such, they are unrelated. And so the translation of John wins and the translation of John may win end up being, well, saying different things, but not only different things, they're saying what it's possible for John to do and what he actually did are unrelated. And that doesn't seem right. Okay. So we're going to get around that by adding what we call covert expressions. A covert expression is one that shows up in the interpretation, but it's not one that you ever pronounce. It doesn't have a pronunciation. And there are two ways that we could do this. They give slightly different formulas, but they end up predicting the same truth values for sentences. The first is to add to our logic, add to our English, I'm sorry, a name W star of the actual world. W star will then translate as W sub A, which is our predicate logic name for the actual world. And so it goes as follows. We take the sentence John wins to involve this W star that combines with wins applied to the translation of John. This we break down into two pieces. The function, that's wins, applied to an argument. That's our W star. And of course, the result of that still has to apply to the translation of John, which is John. Wins now can be exactly the same wins that we used for the modal case. It has a world argument in it because we've given it a world that it can take as its argument. We apply that to W sub A. Now, W sub A has to substitute in place of W prime. The result is going to be lambda x win W sub AX, which will then apply to John, and John will be substituted in place of X. And we get win W sub A John. That is the proposition that John wins at the actual world. Okay. We have another possibility that we could also try out. That is, instead of using an empty world or an empty name for the actual world, we use an empty covert operator. And I'll use the operator act, which is supposed to bring to mind actuality. Okay. Act would be just like may. It would be essentially a modal. But the important difference is that in actuality, the relation that it imposes between the actual world and the world being quantified over here is identity. They have to be the same world. Okay, this says there's some world which, first off, is identical to the actual world, and P of y is true in that world, okay? And now we go through our mechanical lambda applications and lambda conversions. We take act to combine with wins, and we apply its translation to the translation of John. That means we take this time act to be the function term, and wins, its translation is the argument, and then applied to John. Act is up here. Win is here. And this now has to substitute in place of P. Okay. So if we make that substitution, that puts win here in place of P. It has to apply to our world variable W. That has to substitute for W prime. And that then gives you then we have to take the Y and substitute it for the X. And that then gives you win WY. We still have this outside lambda to take care of, and we still have one more argument to apply it to. We take that John and we substitute it now for Y. And we get back, there is some world W, such that W is the actual world, and win W John. Okay, and like I said, these formulas are derived in two different ways, and they give you different formulas. But they each determine the same denotation. That is, this one is true if and only if this one is true, right? This says that there's some world which, among other things, makes win W John true. But that world also has to be identical to W sub A. And so that gives us essentially the same thing that this gives us, win W sub A of John. Okay. So the second part I want to go through is necessity modals. Necessity modals use different quantifiers over modals, for modals. Instead of may, might, can, and could, we have must, will, should, shall, ought to, have to, need. I'm probably missing a few. Okay. And a necessity modal, essentially, we're going to analyze, as we said last week, as universal quantifiers instead of existential quantifiers over worlds. But let's look at what they come across meaning first. I'll look at two different sentences because they have slightly different preferences for their interpretation. One is John must win. Probably the easiest way to interpret that is as a deontic modal, as saying that John is required to win, maybe by the speaker, maybe by his mother, maybe by law, who knows? Okay. So that's a requirement instead of permission, but it's going to be analyzed very similar to the permission modals. John must be the winner. Okay, suppose I see there was a tournament that just finished and I see John with a smile on his face. I don't know what happened in the tournament, but just judging by John's appearance, he must be the winner. Okay, it follows from everything that I know that that John now wins. In this case, I would say John is the winner. You can get a similar interpretation for John must win. It's harder to get, but when I change to John must be the winner, this is the easiest one to get. We can also have a teleological interpretation. It becomes better if we go ahead and we put the goal. So there's a tournament coming up. In order to become famous, John must win. Okay. We have other modals like will. John will win. John will be the winner. Very often people consider will to be a tense. I'm going to consider it to be a modal and see what we can do using it only as a modal. Part of the reason we know that it can be a modal because it can talk about things that are present. And if I look at the outcome, I've checked out the scores. They haven't yet made the announcement, perhaps, but I can say, John will be the winner. It can be talking about the actual present, not even about the future. John, this is like saying John is the winner, almost. Okay. This we're going to give a circumstantial interpretation eventually. It's going to say that the circumstances as they are in the real world guarantee John's winning. It could be guaranteeing John's future winning. It could be guaranteeing John's presently being the winner. And that's a difference between future and present interpretation of these sentences. But that's an additional reading that we can get with will. We don't get that reading with must. We could also have would. Would is like could. It has past shifted readings. So John would win. We were at a tournament last year, and this and that, and et cetera, what happened. And John would maybe would win the next day. John would be the winner as well. It could be, these could be in the past circumstances guaranteed John's winning. We can also do it with a goal of some sort. In order to become famous, John would win. Saying in the past, the only way to reach a goal was for him to win. I've given here a chart that gives you an idea of just how many different modals we have to deal with and how many different interpretations. I didn't go into the hypothetical ones over here. A hypothetical, only thing that works hypothetically is would. And if you talk about a situation that's not real, then you can use would to talk about the consequences of some circumstances, for example. But I'm not going to go through all the details of the different modals on this chart, just to give you an idea of the kinds of things we need to explain. Okay, now I said we're going to be treating these all as universal quantifiers. And they all have their own ranges of interpretations. But what happens if we look at just one of those interpretations? Do the modals all give the same interpretation? Well, in language, that would be a fairly odd thing. Usually, if you have 2 or 3 different words that are similar, they're also, in some important way, different. There's a saying that comes from the old days of doing linguistics in the early 20th century, no difference without a difference. And the words will, must, and should are different words. So if you're going to use them, you should expect different effects. So let's look at teleological interpretations. We're going to take the sentence, to get from Kyoto to Tokyo, you will take the Shinkansen. Okay, that might be true. To get from Kyoto to Tokyo, you must take the Shinkansen. That doesn't seem true. There are other ways to go other than by Shinkansen. You can take a local train, you can drive. To get from Kyoto to Tokyo, you should take the Shinkansen. That one seems true, at least possibly true again. Okay, so let's first see if we can characterize exactly what those differences are, and then ask how can we explain them by giving will, must, and should slightly different interpretations. So let's look at the sentence with will first. To get from Kyoto to Tokyo, you will take the Shinkansen. This is true if and only if taking the Shinkansen is the actual way you get from Kyoto to Tokyo. If you don't go from Kyoto to Tokyo, then this sentence is false. If you do go, but you go by car, this sentence is false. The fact that there are other ways of going that you just don't happen to use, that doesn't matter. Yeah, some people can fly, some people can walk, but you will take the Shinkansen. As long as that's the actual way you go, then the sentence will be fine, will be true. Okay. We make a small change from will to must. to get from Kyoto to Tokyo, you must take the Shinkansen. That's going to be true if and only if taking the Shinkansen is the only way of getting from Kyoto to Tokyo. And as we said, that's not true. You can go by plane, bus, car, bicycle, all sorts of other ways you can get from Kyoto to Tokyo. They might take longer. They might not be as comfortable, but you can do them. And that makes this sentence false. The last one, you can, to get from Kyoto to Tokyo, you should take the Shinkansen. Well, that's true if taking the Shinkansen is somehow the best way of getting from Kyoto to Tokyo, according to the speaker, right? It's an acknowledgement that there are other possibilities, but it says this way is somehow better than all of the other ones. This is what you should do. Okay. So now let's start working toward an analysis, a formal analysis. In chapter 7, we analyzed teleological modals as quantifying over worlds in which a certain goal is reached. Okay. The circumstances related to reaching that goal were taken to be identical to what they are in the actual world. And those circumstances have to be held constant for the worlds quantified over. Except we made an exception. The exception was the truth of the prejacent, which can differ. So the prejacent in you must take the Shinkansen is you take the Shinkansen, okay? And we said that that can be true or false, but we don't hold that constant across all of our worlds when we're quantifying. We allow that to differ, but we keep all the other circumstances the same. Okay. Now, to make things a little bit easier, I am going to use an abbreviation. Okay. To restrict the circumstances, we said this in the previous chapter, that every P, where P is a circumstance of the actual world relevant to the goal G, and P is not the circumstance Q, which is the prejacent, and P is not the negation of Q, then P of W and P, the truth value of P at W is the same as the truth value of P at the actual world, okay? And we're gonna take that whole thing and abbreviate it just like this. We're gonna call it circ. We're gonna give it 3 arguments: the actual world, the prejacent, and the goal. And so this says that world W shares with the actual world all circumstances related to the goal G, except perhaps for Q or not Q. Okay? Now that makes our formulas a lot simpler to write and a lot simpler to read. So can Q, where Q is a prejacent, with respect to a goal of G, would be given this in a much simplified version of what we had from last chapter. It says there's some world W where the circumstances of W are like the circumstances of the actual world with respect to G, except perhaps for Q. And G, the goal, holds in that world. And Q, the prejacent, also holds in that world. Okay. We're going to do something very similar for must, except we're going to use the universal quantifier for must, which comes with an arrow instead of an and sign here. And I will be calling this piece that's shared in these 2 formulas the restriction on the quantifier. Okay, so this says that every world that shares the relevant circumstances with the actual world and in which the goal is reached is such that the prejacent is true of that world. Okay. Now let's go ahead and apply that to our case, to our example. Our example is to get from Kyoto to Tokyo, you must take the Shinkansen. The interpretation I just gave actually works pretty well as an interpretation of must, and so we're going to use it. And we're just going to give it exactly the way it was given up above and put below what the goal G is and what the prejacent Q is. Okay. The goal is you get from Kyoto to Tokyo. And we can spell that out like this. This is a property of being a world at which there's some P, which is a path, and you get that along that path in W. And the path goes from Kyoto into Tokyo. Okay. And the goal, sorry, not the goal, that is the goal. And the prejacent, Q, is the property of being a W such that you take the Shinkansen in W. Okay. So the sentence is true if and only if in every world in which two things hold, you take the Shinkansen. Those two things are, first, the circumstances related to getting from Kyoto to Tokyo are as they are in the actual world, except perhaps for the circumstance if you're taking the Shinkansen. We allow worlds in which you do take the Shinkansen. We allow worlds in which you don't. Okay. And also in every world that we're looking at, you get from Kyoto to Tokyo. Okay. So this says that in all of those worlds, you take the Shinkansen. Now we know that's false. The circumstances related to getting from Kyoto to Tokyo include that it's possible to make the trip by plane, car, bus, etc. And that means that there are worlds in which the circumstances are just like they are in the actual world, in which you get from Kyoto to Tokyo, say, by car, without taking the Shinkansen. Okay. Up here it said every world in which these things hold, you take the Shinkansen. But we know there's at least one exception, one where you take a car instead. And that makes the sentence predicted to be false. Well, that's good because the sentence is false. The prediction matches the observation. Okay, so if that's our way of analyzing must, how do we get the differences between must, will, and should? I'm going to look at will first, and then afterwards we'll look at should. And we're going to do it like this. With must Q, we said the circumstances related to the goal have to be the same in all of the worlds quantified over as they are in the actual world, except we made an exception for Q, right? We want to at least allow other possible ways of getting from Kyoto to Tokyo. We don't want to fix it that you go by Shinkansen in all of the worlds we look at. Well, with will, perhaps that's exactly what we do want to do. We want to say, look at all of the worlds that share all of the relevant circumstances with no exceptions. Let's see what that would do for us. We have the sentence, to get from Kyoto to Tokyo, you will take the Shinkansen. Will quantifies over worlds in which all circumstances related to you getting from Kyoto to Tokyo are the same as they are in the actual world, that includes the circumstances of how you actually go. The sentence is true if you take the Shinkansen in each of these worlds, right? Whether you take the Shinkansen or not is a circumstance related to you getting from Kyoto to Tokyo. It was one that we didn't care about for must, but we do care about now for will. If you take the Shinkansen in the actual world, then you take the Shinkansen in all worlds being quantified over, because that's one of the circumstances that has to be the same in all of those worlds. Well, if it's held the same in all of those worlds, then of course you take the Shinkansen in all of them. And the sentence, you will take the Shinkansen, comes out true. If you do not take the Shinkansen in the actual world, then you don't take the Shinkansen in any other of the worlds being quantified over, because that has to be held the same across all of those worlds. And this makes the sentence false. To be true, you have to take the Shinkansen in every world quantified over. And this says that you take the Shinkansen in none of them. And so the sentence is false. Okay, how are we going to do this formally? We're going to make just a very slight adjustment. Instead of this, circumstances, which included an exception for Q, we're going to use a different abbreviation that doesn't have those exceptions. It's going to be circ prime. It only has two subscripts, the actual world and the goal. It doesn't have the prejacent as a subscript. Okay, so our old one says our old requirement had this as our exception clause. Our new one just takes that out. Everything else is the same. It says for all P, the circumstances in world WA, if P is a circumstance of world WA with respect to the goal of G, then the truth value of P is equal to the truth value, and W is equal to the truth value of P at the actual world. Okay, so this new restriction doesn't exclude worlds it doesn't exclude the prejacent from the circumstances that have to be the same in the two worlds. The prejacent also has to be the same in the two worlds. Okay, so this gives us a translation for will Q, which looks very similar to must, except we've used our new set of circumstances here. Now, this set of circumstances actually guarantees that the actual world will be among the worlds quantified over. It says, look at all the worlds in which the circumstances are exactly as they are in the actual world. No exceptions. Well, the actual world is one of the worlds where all of those circumstances hold. And by definition, that's what we're using to define the worlds. Of course, it's going to meet that definition. So that means that will Q is only going to be true if Q itself is true. So when I say to get from Kyoto to Tokyo, you will take the Shinkansen, I am essentially saying, among other things, that you do take the Shinkansen in this world. That's something that actually happens. I could be wrong. I can be wrong about everything, but that's what I would be saying. Okay, next, to get from Kyoto to Tokyo, you should take the Shinkansen. And we said before that's true if and only if taking the Shinkansen is the best way to get, for you to get from Kyoto to Tokyo. And this has properties, some of which are like will, some of which are like must. Like will, it allows for there to be other ways of getting from Kyoto to Tokyo. Okay. Must didn't allow that. In order for the must sentence to be true, that had to be the only way of going. And but for will, it didn't matter. Like must and unlike will, it doesn't require that you actually go by Shinkansen. I can easily say this and it can be true, and you may decide to follow somebody else's advice and go by car, or you may decide not to go at all. The sentence will still be true. Okay, the fact that should does not require that you actually go from Kyoto to Tokyo by Shinkansen shows that with should Q, the worlds quantified over do not have to contain the actual world. It's like must in this respect. And with must, we actually got that consequence by using a circumstance that allowed things to differ with respect to a particular proposition. Q in particular didn't have to be the same in the worlds quantified over as it was in the actual world. And if it differed, then the actual world wouldn't be one of those. To account for the fact that Q allows ways of reaching a goal G other than Q, we take should to include a second, often unstated goal. And we're going to put that in here as this C of W, okay? The idea is this: we're still going to make it a universal quantification. It's very similar to must, except must only cares about circumstances and the goal. Should cares about something else. That something else, for example, could be to make the trip as comfortably as possible. Maybe I think that that's a very important thing. I don't say it, but that's why I think you should take the Shinkansen, because it's so much more comfortable than driving. Okay. So there may be many ways to reach the goal, but only one of them that makes it the most comfortable. Okay. That's what this is going to require. It's going to require that there's exactly one way of reaching the goal and satisfying C, and that has to be doing Q, whatever Q is. Okay, so going by Shinkansen does not have to be the only way of going from Kyoto to Tokyo, but it does have to be, for example, the only way to go from Kyoto to Tokyo in the most comfortable way available. So summarizing, we have these as our three different teleological interpretations. They all look similar, but they all have important differences. Must quantifies over worlds sharing circumstances with the actual, except perhaps for the prejacent, and worlds in which the goal is reached. Will uses slightly different set of circumstances, but requires a goal to be reached. Should uses all the same things that must does here, but it adds an extra restriction. And all the rest ends up the same. Okay, we're going to turn next to epistemic interpretation. Epistemic interpretation was slightly different. Here's an example of a situation where an epistemic interpretation is very natural. We're in a room and we hear a knock at the door. I can say any of the following 3 sentences. Oh, that'll be John. Or that must be John. Or that should be John. All 3 sentences say roughly that that is John. That is John is compatible with what I know. Or maybe even stronger, that it follows from what I know. But they're not all identical. And so the first thing is to try to find out how they differ. And I'm going to give you 2 ways, 2 different situations where they come out saying different things. And we can notice that difference because one of them is appropriate and the others are not. So let's go with a slightly different situation. There's a knock at the door, and the first thing I say is, that might not be John, because I have a sense that there's a possibility that it isn't. But I follow up with, however, that should be John. No problem here. But if I try the same thing with must and will, it comes across as a contradiction. I say, that might not be John. However, that must be John. There I very straightforwardly feel like I've contradicted myself. I've said 2 things that can't both be true. Or that might not be John. However, that'll be John. Again, comes across as a straightforward contradiction. So there's something different about should that sets it apart from must and will. And we want to know why that we want an analysis that predicts those facts. Okay. For the next one, we're going to change the situation again. We're going to start off with a knock. And you ask me, who is that? And I answer, I don't know. John's the only person in the building. However, Mary's the only person who ever comes here. Now, first off, in that situation, none of these sentences come across as any good. I can't say that should be John. I can't say that should be Mary. I can't say that must be John. I can't say that must be Mary. I can't say that'll be John. I can't say that'll be Mary. None of them are good. But we can add something to make some of them good, 2 of them. So we start with the same circumstance. There's a knock at the door, that's the same. You ask the question, that's the same. I give, I don't know. John's the only person in the building. However, Mary is the only person who ever comes here. But now I give this as a sentence. Given that John's the only person in the building, that should be John. No, that works. Given that John is the only person in the building, that must be John. That also works. Given that John is the only person in the building, that'll be John. That one doesn't work. So should and must are patterning together here, and will is the odd one out. Okay. I could also say, given that Mary is the only person who ever comes here, that should be Mary. Or given that Mary is the only person who ever comes here, that must be Mary. But I can't do the same thing with will. And what's interesting here is that I can actually do both of the one. If I use the good should or must, I can do both. So I can say, well, given that John's the only person in the building, that should be John. But given that Mary's the only person who ever comes, that should be Mary. So I don't know who it is. Okay, that's a perfectly fine thing to say. Okay, so how are we going to explain it? We're going to do the same kind of a thing we've done in all of our past analyses. We're going to analyze the difference as the difference in the worlds being quantified over. With will, we're going to say these worlds always include the actual world. And with must and should, they don't have to. Then we're going to add another distinction. Will and must are only going to place one restriction on the worlds quantified over. That's compatibility with what someone knows. Should, we're going to say adds a second restriction, one that doesn't have to be known. This is very similar to what we did in the previous analysis of the teleological modals. Remember that with should, we added this extra restriction, C of W. That was different from the goal. Here, we're going to add a C of W that's different from what's known. Okay? And we're going to use those two differences to explain the data that we just saw. Okay. So first off, how do we get these restrictions in there? To get will to include the actual world in all of the worlds it quantifies over, we require the knowledge that restricts that quantification to be correct. Sometimes I can say, I know something and I'm wrong, okay? But if we only look at the world, at the knowledge that I have that's actually correct, that's knowledge that holds of the actual world, okay? We take will to always impose that requirement. The knowledge that you're using is correct knowledge about the actual world. With should and must, we don't make that requirement. We could say that should and must actually use belief instead of knowledge. That would be maybe a nicer way to make the distinction. Or we could say that should and must allow knowledge that is perhaps mistaken. Okay. Now, if will quantifies over worlds that have certain knowledge held constant, and it says in all of those worlds, Q holds, and the actual world is one of those worlds, that means Q holds in the actual world. That gives us will Q entails Q. With should and must, they're quantifying over worlds where everything I believe, I think I know is true, but some of it might be wrong. Okay. So the actual world might not be one of the worlds that satisfy everything I think I know. Maybe I think I know that it's raining outside, but in fact it's not. Okay, then the actual world is not one of the worlds where everything I think I know holds. Okay, so should Q, must Q, don't tell us definitely that Q is true. Might be, might not. Okay, let's now turn to some predictions of this analysis. We haven't finished the full analysis, but we've got a part of it that we can use and see where it leads us. If we say that will be John, we've heard a knock at the door, that entails that that is John. And when you say that is John in English, you actually mean that that is John alone. It's not John among a lot of other people, it's just John, okay? Similarly, if you say that'll be Mary, you entail that that is Mary, and it's Mary alone, only Mary. Well, it's not possible for the person at the door to be John alone and for the person at the door to be Mary alone at the same time. And so it's not possible to say that will be John and that will be Mary about that same situation either. So this is a good consequence. It tells us that we can't have the two sentences, that'll be John and that'll be Mary, both true at the same time, in the same circumstances. The problem is if we stop here and don't say anything else, then we get the consequence that that must be John and that must be Mary should be contradictory, just like with will, but for a different reason. With will, the reason was because of what it says about the actual world. With must, it's because of what it says about all of the other possible worlds. It says in all of those worlds in which things are the way I believe them ought to be, that is John. And in all of those worlds, that is Mary. Well, that's again a contradiction. You can't have a unique person at the door be John and be Mary in any world. And so it can't be the way in all of the worlds you look at either. So if both sentences are quantifying over the exact same set of worlds, the restrictions they place on those worlds can't be met. So we're going to get around that problem by allowing must to quantify over just a smaller part of the knowledge of a person's knowledge. I'll call it some relevant body of knowledge. My knowledge about mathematics pretty much doesn't matter when you're talking about whether that's John or not at the door. Okay, we ignore my knowledge of mathematics. My knowledge of what's happening in the United States isn't going to matter if this sentence is uttered by me while I'm in Japan. Okay. So we only look at relevant body of knowledge. Doesn't have to be anything, everything I mean, that I know. And furthermore, we allow ourselves to change what that important body of knowledge is. So let's go back to the situation here. I said, given that John is the only person in the building, that must be John. That's one of the pieces of knowledge that I have. By stating it here, I can now say, let's look at all worlds in which this is the piece of knowledge that counts. In every one of those worlds, that is John. Okay. Here, I have a different piece of knowledge. This is the knowledge that Mary's the only person who ever comes here. Let's get the comes here. Okay. If I look at all the worlds that hold that constant, in all of those, that's Mary. Now, since here is in this building, it's not possible for both of those two pieces of knowledge to both be true at any given world, any single world. So the worlds that are quantified over up above, the John's the only person in the building worlds are over here, that's one set. And the Mary is the only person who ever comes here worlds, yeah, it's a different set. They're separated, they're different. There's no overlap. And so these two sentences are putting restrictions on different worlds, and those restrictions can be met by those different worlds without any problem. So I put it this way, that must be John is true relative to the possibly incorrect knowledge that John is the only other person in the building. That must be Mary is true relative to the possibly incorrect knowledge that Mary is the only person who ever comes here. Okay. As long as I can interpret the same sentence with respect to two completely different assumed pieces of knowledge, they can both come out true. Okay. Because there's no requirement that any single world be among the set of worlds quantified over by the two in the two different cases. Now, we'll observe that if we don't have any context, if there's a knock at the door and I simply say, ah, that must be John. Ah, that must be Mary. That sounds contradictory. Okay. So it seems that unless we make an explicit restriction, we say this is the piece of knowledge that counts. Unless we do that, we're going to use the same knowledge in both cases. And if we use the same knowledge in both cases, then it does come out as a contradiction. It's predicted to come out as a contradiction. Okay. Okay. So now let's go through the case. I believe I used may before instead of might here, but it works with both, might or may. There's a knock at the door. I say that might not be John. However, it should be John. That was okay. However, that must be John. That was not okay. Okay. That will be John. That's not okay. Okay. I've given one modal sentence here, and I followed it up with another modal sentence here, and I haven't said anything about what knowledge I should be talking about. That is, in particular, I haven't changed the knowledge that I take to be relevant for the two sentences. So what we said before is that that means we should be interpreting them both with respect to the same set of knowledge, whatever it is. Knowledge relevant to the circumstances here in Japan. Okay. We'll take that knowledge, whatever it is, to be K, okay? It doesn't really matter what K is. The important thing is that it's the same knowledge K that might is quantifying, using for quantification here, and that should, must, and will use for quantification here. Okay, so that's what this says. Should, must, and will quantify over worlds compatible with that knowledge. And we're going to call those worlds W sub K. Okay, so the K is the actual knowledge. W sub K is the worlds in which that knowledge holds. And now for our proposal. Must quantifies over those worlds with no further restrictions. The knowledge could be correct, it could be incorrect. It doesn't say. Will quantifies over those worlds, except that it requires K to be correct. Okay, that's the correct knowledge. But should quantifies over slightly different worlds. It quantifies over worlds in which both K and some other restriction, C, both hold. And we'll call those worlds W sub K, if I can get it, K plus C. There we go. Okay. Worlds in which both K and C hold. Okay, so let's go ahead and give the analyses. That may not be John is going to be true if and only if there's some world in W sub K in which that is not John. That must be John, or that will be John, is going to be true if and only if in every world in WK that is John. Well, that can't be John in every world and not be John in one of the worlds at the same time. That's a contradiction. So our analysis explains our intuition. Our analysis generates a contradiction, and we feel like it should be a contradiction, and so we're happy. With should, on the other hand, we're quantifying over different worlds. That may not be John says that in W sub K, there's some world in there in which that's not John. But that should be John is quantifying over a different set, W sub K plus C. It says in every one of those, that is John. And this is not a contradiction. We'll show that here. So there's some knowledge, K. It's going to determine a set of worlds in which everything known is true. That's here. There's some other restriction, C. That's going to determine a set of no worlds in which C is true. That's here. In the middle, we have those worlds in which both K and C are true. Should is saying that in all of these worlds, that is John. May is saying that at least one of these worlds, in one of them, that's not John. So if that is John in all of these worlds, but it's not John in some world out here, both of those are true. There's no problem. There's no contradiction. Our analysis gives no contradiction. Our intuition says there is no contradiction. Our intuition matches the analysis. So we're going to give the formalization again like this. KW will just say that W is a world in which compatible with what the speaker knows. Okay. With will, we add the extra restriction that the actual world has to be compatible with what the speaker knows. The speaker's knowledge has to actually be true. We don't add that for must. And for should, we also don't add it, but we add a separate restriction, something that's given by the context. We haven't said what that is, but some separate restriction. And that makes it possible for should Q to go together with may not Q. Okay. Okay, that's what we have for this week. I will see you again next week.